Welcome to December 10th LeetCode Challenge, Transpose Matrix. Given a 2D integer array matrix, return the transpose of matrix. The transpose of a matrix is the matrix flips over its main diagonal, switching the matrix row with the column indices. So if we're given this matrix as example here, we have the rows, and outline this color. If we were to transpose it, all the rows become columns along the diagonal. So 2, 5, and 6 are diagonals here. So say if we're given this example number 1, this matrix right here, we're given basic 1, 2, 3. The next row contains 4, 5, 6. And the last remaining row is 7, 8, 9. If we were to transpose this 3 by 3 matrix, it will look like this. So all the rows becomes column. So rows 1, 2, 3 becomes column 1, 2, 3. Then we would have, this would be 4, 5, and 8. No, wait, 6. And then this would be 7, 8, and 9. So now it would become 1, 4, 7, 2, 5, 8, 3, 6, 9. This is the transpose of this matrix right here. Say we have the matrix example number 2 here. We have the matrix of, I believe it's 2 by 3. It looks something like this. Therefore, if we transpose this matrix, we would just remove the last line right here. And therefore, all the rows becomes columns now, and it looks like a 2 by 3 matrix. And that's pretty much the gist behind that. So how do you go about solving this? First, let's look at some of the constraints. M is the length of the matrix. N is the length of the matrix of the specific index, so which would be the row. M and N are values between 1 to 1,000. M times N, so this is the dimension, would be 1 times 10, between 1 to 10 times 10 to the 5. Each value within each value within each cell, or so that's the index of ij in matrix, is between negative 10 to the 9 to 10 to the 9. So intuitively, how do we go about solving this? Well, we could just go directly and make a copy of the matrix. So basically, we copy the rows to the columns, and we just remake the matrix. So the transpose of a matrix within dimensions of rows and columns times columns is a matrix that we can make an output matrix with the dimensions of columns times row. So we just basically reverse the rows and columns, and we swap it. So let's kind of use that method. It might not be the best approach, but it is an approach that will work. So say we have a integer that holds the row, and we initialize that to so what should be m right here. I'll go ahead and call it m. Let's call it m, and that's gonna be matrix.length. Kind of using the same notation there, and then we also have something called, we initialize another variable, I believe, called column, or n, and that's gonna be matrix at index 0, so it'd be the first column. Doesn't really matter which one, but as long as it has a column that is existing. So we have an integer m and integer n, which is the row and column of the matrix. For each integer row equal to 0, we want to find such that row is less than m, which is the row there. Then we want to increment our count. By doing so, we loop through each row, and for each row we want to look for the column as well. So for each column equal to 0, we have it such that the column must be less than the column length, and then we also want to increment our column count. So basically, this is as you can see, it's a nested for loop. Not the ideal, but it will work. Oh, and we also have to initialize our output, which is gonna be our call our output and array, and that's gonna be a matrix as well. So it needs to return a integer two-dimensional array, and that's gonna be initialized to new integer two-dimensional array. And we're gonna actually populate that with the size of the. So before initially we have row times columns, then we want columns times row. In order to do the transposition. So this would mean that this would be n and this would be m. Because before it was m times n, and now it would be n times m. And now that we have it initialized, we want to assign the variable called output. And what do we want to assign? We want to assign the columns and the rows. And what do we want those values to be? We want the values to be the matrix, the old matrix. We want the old matrix row to become the new output column, and the old matrix column to become the new matrix row. And then we just do a for loop for all the dimensions. And then when we exit this for loop, what we could do is return our output as such. Let's run this. This might take a long time because output, let me see. Oh, I forgot a semicolon. Rookie mistake. All right, looks like it's accepted for there. So what we could do, oh, accepted, nice. So in terms of transposition, I think this might directly copying the rows to column might be the only method because we have to iterate through each individual cell in the matrix, and there's no way of shortening. Hopefully, I mean at this point I don't know of any way to shorten the time complexity. But just to look at it here, we have nested for loop. So time complexity would be row times column. So that's where m times n, I should say, where that's the number of rows and columns given the matrix. Space complexity, we directly copy the old matrix and we make a new one. So the space complexity is equal to the size of the matrix, which is row times column, or m times n again. So it is pretty slow. Luckily, our dimensions aren't too terribly high, but that's pretty much the direct copy of our matrix transposition function. All right, have a great day, everyone.